All right, welcome back. So, Lee, what'd you find?
Stuff and things.
Hmm.
Yeah, mostly things that I had screwed up. I was forgetting that patch position, this particular position right here, is in patch coordinates, which means not world coordinates, which is the whole reason why we have world position. So the difference is the fact world position takes into consideration the size of the patch and the spacing of the vertices in between each of the vertices. So while the patch was reporting, say, 1-1 for a patch that was to the north and to the right of a patch looking down from it, it would say 1-1, but I was comparing that against a player's position, which is in real world units. So I need to convert the patch position to world position coordinates so the two coordinate systems are the same. So that's where I had made my mistake. So basically, up here where it says position, change those to world position. And each place down here where it says position, these will also get changed to world position. So, and that just says normalized over here. So let me go ahead and I'll wrap this in Control N, Control X, put that down here, just so I can keep everything on the screen, hopefully. And it's still not all on the screen. What else can I do? Okay, forget this. Not going to be perfect, but if it makes it easier for people to see all the code at once so they can type it, I think that's a better solution. So there. That should be a little bit easier for everybody to read. All right, so these get changed to world position, but that's not the only thing that we have to change. Right now, we're now checking the player's position in world coordinates, the patch's position in world coordinates, but we're checking to see if it's greater than equal our interest range. And our interest range is not taking into consideration the size of the patch. So I need to multiply this by our train manager dot patch size, because I've already done the calculations that I can draw upon to calculate the overall patch size. So this should be everything that I need. At least I think it is. So if I jump over, oh
Which,
yeah, when I
yeah,
was testing, I exploded Unity when I was showing you that eventually a memory leak will eat the editor alive and it will explode. Yeah, while we were doing testing, we caused it to explode. Of course, thinking we were running at 710 meters a second too,
this
so
is true.
which was quite humorous to watch. But let's go ahead and load up the scene. Let's grab our character. I'm going to ramp her speed up for, say, about 30 to start with right now. Go ahead and hit play. All right, so here we go. Go ahead and zoom out a little bit. And as you can see, we can spin around. Hey, look, it broke again. Nice. Which means obviously I missed something somewhere. All right, what did I miss and where? All right, patch position. This is world position. That's world position. So that's position. That's position. And rescind. Yes. Now I'm rescinding patch position as opposed to this one. So let's go and take patch dot position as opposed to world position. and try that again. All right, so now if I spin around, and we're still broke. And no errors to help. Nice. This didn't happen last time. You notice that?
Yeah, something's still different.
Yep. I missed something somewhere. All right, so interest range, patch, position. Did I miss one of these? Position, MySQL, order by. It's greater than interest range, cam.
Here, I'll help you out real quick. I'll go ahead and just pause the video
Yeah.
and let you just hunt through this real quick.
Okay.
All right.
Yeah, no, I really hate it when it's something simple. Especially when it's so simple that you just completely overlook it. Rescind wants a vector 2, and I just sent it a vector 3, which meant I'm not sending it in the right information. So what I need to do is convert to a vector 2 my patch position using its x and its z, and instead of sending in its x and y information, which is what I was doing.
Mm-hmm.
So now if I run, and give it a sec, and there we go. So now if we start running at some really fun speeds. What speed am I running at, by the way?
You put 30 in there?
Yep, 30. So, but I don't think 30 is fun enough. Do you think 30 is fun enough?
Fun enough. Sure, adjust it.
Well, we knew that 70 was breaking it before.
Yeah, for sure.
So let's play with 70. So we seem to be running just fine at 70 right now. Now, you'll notice there's some artifacting in the background with it being destroyed or removed. And that is just because I've prioritized the construction of patches over the destruction of patches. So if we pick back up, then we can see that we're getting our patches taken care of. Now you'll also notice we see a whole lot more patches than we ought to be at this moment in time. The reason for that is because there's another bit of debugging that I did that I didn't undo, which is the code that hides our information outside of our view frustum. So you won't even see that stuff with that code turned on. So if I drop in now, we were proving that 70 worked. Let's try 100. So here we go. So we're just cruising right along at 100 meters a second.
Very nice. Very nice.
And if I drop, so now in reality, you probably don't want to be moving this fast with this system, but for the most part, it does work. So some artifacts, just because it can't keep up, because what is ending up happening is we're removing all these patches. Or there's so many patches that are queued up that would be removed that they're not being picked up by the rest of the code. Because if we look at our code, where we're set up, we're saying, where are we? Tray manager. We're saying, hey, queue these patches up and remove them, but we're only doing one at a time, and they're never getting removed because they're getting outside that range. Mm-hmm. We could clean this code up if we really, really needed to, but then we start getting into a performance issue. Basically, if I were to do something like take this entire section of code. So we're going to hide patches first, even if they're about to be removed, and then get rid of this break. Then we can run this again. Let me rebuild just to make sure that it picks it up. Take our character, jump the speed up, and then just start running. And actually, that's not half bad with these patches. Looks like the system can handle it in this configuration.
Yeah, it does. All right, turn left. Nice. Heck
And
yeah.
you can see all the patches that were still in memory. All right, well that's 100. How about 150? And we're still
going.
cruising along. 200, anybody?
Ooh, you're going to start getting close, I think.
I think I'm going to run out of memory first.
Oh, that's true. Oh, close, though.
Okay, 200. 300, anybody?
Here comes the big explosion. That's where we'll close the video down at that point.
Yeah, at some point, matter of fact, I can look and see how far off we're going to be. Bring up Task Manager. We're already in excess of 1 gig of memory.
Yeah.
At about 1500, this will completely close. We're going to get a garbage collection error. Wow, I'm moving
Nice
really
jump.
fast.
I told you.
Look at it, it's desperate.
It's still,
like going.
Oh, barely.
It's like going. I can do it. I can do it. So yeah, we're still holding at 300 meters a second.
I'm impressed.
So, and this is without threading. So all you guys that were worried about lag, I'd say we got that nicked.
Again, using asset bundles, Unity Pro, we just want to have really, really far, view scenes. Yeah.
Right. And nobody in their right mind would want to move this fast.
No. You're going to have some very serious issues if you were on the ground running this fast, and we got to start worried about bringing in all of our decoration models and our hero models and all.
How far away did I get? Quite a ways. So, but, I think this is more than adequate for our standard users.
Yeah.
So, I'd say we got most of the issues resolved on this one.
All right, so where does that put us next? What are we going to be looking at? Are we going to start moving into Vertex and Vertex Cache now?
Well, we can't do the Vertex Cache until we have a Vertex in place, because the Vertex Cache stores a whole bunch of information for each of our vertices.
Right.
So we're going to create a Vertex Cache, which is going to hold all of our information. And then from there, we're going to get into a Vertex Cache.
No, you said it wrong. We're going to create a Vertex once we get the Vertex class in place. Then we're going to move on to the Vertex Cache.
I thought that's what I said.
You said Vertex Cache twice.
Well,
You said we're going to make a Vertex Cache, and then we're going to move on and make a Vertex Cache. All right.
Well, there's the Vertex Cache, and then there's the Vertex Cache, which is completely different than the Vertex Cache, which comes even later.
It's too much cache.
Oh, there's no such thing as too much cache.
Yeah, I guess that's true.
It's like going, if you've got too much cache, I know what you can do with the rest of it.
Yep.
So, but yeah, I'd say this is a good stopping point for now, and then we can look at the Vertex class in the next video.
Awesome. Sounds fantastic. All right. Well, thank you guys very much, and we'll see you in the next video.